Andy Bennett from Tailvent is going to show yet a different flavor of geodesign using utilities. Andy? Good.
Okay, yeah, I just want to take a few minutes to talk about geodesign in the context of the way a distribution utility, specifically electric utilities, actually operate. So probably the first question is, why do we need to do design at a utility? You guys probably look out front yard, you see a pole. Doesn't look like it changes all that often, but the network, the distribution network, the electrical network that brings us electricity to our homes is one that is pretty dynamic. And it changes fairly constantly. And there's some obvious changes, right? We have new subdivision designs, new homes that come into our communities. And then, of course, we have these new challenges with the ever-increasing need for more power, right? And so we have capacity issues, and those capacity issues dictate design as well. And then utilities go through a lot of seasonal change. So they're always redesigning their systems to shift electrical load to areas that need more power. And then, of course, one of the most obvious reasons for design and the continued nature of design is because we have electric outages, right? There's storms, poles get knocked down. We've all experienced this. And so all of those things really necessitate the need for geodatabase and geodesign within a distribution utility. So I guess just a couple of the goals and the ways a utility think about this. And the first thing is that all the design that most utilities are doing on their distribution systems are based on the fundamental concept of using the GIS, mainly because that GIS is already where all of their assets are stored, right? That's the as-built nature of the network. But there's a lot of other reasons why utilities find this very attractive, right? They're always looking for ways to streamline that design process and to reduce that backlog. You can imagine if you have thousands and thousands and thousands of designs taking place on your network every year, right, that you don't have a very streamlined process to get those things posted and into your as-built state, then that could cause a lot of problems. That could cause problems with the nature of the network being out of date and things of that nature. But there's a lot of other reasons why utilities do this as well. There's certainly the problem of aging workforce. A lot of folks are leaving the utility industry. And that's leaving an industry that really has still the continued problem of designing, but not necessarily having the engineering prowess and experience to do that. So that sort of necessitates the idea of more and more design tools to help with that. So just real briefly, a little bit about the anatomy of a design. This is not always the way a utility thinks about it, but frequently is. Really at the top level, we think about a work request or a work package. And that's the concept of all the work we're going to do to get a certain job done. And then within a work request, we may have many designs, right? So that's kind of a many-to-one ratio. You may want to do a design that's an underground design and then also do the design that's overhead and maybe compare and contrast those two designs for things like cost. Every design has at least one estimate, right? One cost estimate associated with it. And then many designers will use this concept of a work location. And that's really just a place within my design, a logical place where I may drop off equipment or associate equipment as I start to think about how I parse up that design. And then this last concept is these designs are really comprised of something that we call compatible units or assemblies. So if you think about that pole, for instance, it might be a pole, there might be brackets and sidearms and things on that pole. So all those materials, the pole and the nuts and the bolts and that sort of stuff, in addition to that, the labor associated with putting that pole in the ground, all that stuff gets formed into this concept of a compatible unit. So as a utility designer is doing a design and they're laying out the electrical infrastructure, they're not just placing features, they're placing compatible units, they're building up labor, they're building up cost, they're building up the concept of the entire job. So just real briefly on this concept of the anatomy, we think about those things like those work locations. Those are some numbered work locations, and then a list of the compatible units that will be associated with those work locations. And then always in a design, the design standards are sort of captured. And on this design, this is a pretty simple one here. You can see the symbology here showing that this entire conductor is going to be replaced or upgraded everything green is going to be new. And the symbology really helps dictate and let people know the difference between what's existing infrastructure versus what's new. And then, of course, there's a lot of detail on construction notes. I know we don't generally think of electrical engineers as being the most artistic type people, but you'd be surprised at just the wealth of information that people put into these drawings. So just a little bit more on the workflow, because the workflow aspect of design is really one of the most important parts. The sketch is the final product, but how that design moves through its life cycle is pretty critical. So this is just a very simple workflow, right? This is the idea that a designer may create a design. They'll send out a work packet to a construction crew. That construction crew will build it. They'll get back some as-built information. The complexity of those designs can get more varied. You think about how that design might traverse and move through from the time it gets sketched to the time it actually gets built. There might be many, many iterations of folks that want to look at that design to validate the electrical standards, to make sure that the design is sound. And so there's all sorts of different workflows that are associated with that. This is a real workflow from a fairly large distribution utility. It's not unusual. And at the end of the day, it looks really complex. It probably is pretty complex. That's a reflection, I think, of just the amount of collaboration that goes on within a utility. One person doesn't build a design and then go out, put up those poles or dig those trenches. There's many, many, many people that are involved in that process, both to oversee the financial requirements, the electrical requirements, the safety requirements. And so these type of design processes can get very, very, very involved, as you can see. So the complexity of the designs, of course, varies immensely too. This is a very simple design. This is maybe the idea of a 3-pole extension. Maybe you have a new residential house. Someone has to put up those poles. They may do some structural analysis of the poles and make sure that they can sustain that. And then there's much more complex type designs. Right? This is the idea of an underground design where you might even need some idea of the manhole diagrams, what's going on in the manholes, where conductors coming in. And often designers will put all sorts of information about the trenching detail. That becomes critical as you're dealing with many, many, many different types of utilities. You don't want to dig into an electrical utility or a fiber utility or something of that nature. So one of the other concepts that we have within design that's pretty important is the idea that these people aren't doing this in isolation. There might be hundreds or thousands of designs going on within an organization at any given time. This is probably a little hard to see, but this yellow area denotes a one person's design, and this green area is someone else's design. And you can see that they're both tapping off of the same facility. And that idea of people multi-editing, needing to communicate, is pretty principal to the overall concept. These designs also may go on for years and years. This is a highway widening project where you might be moving some conductor. And that means that different areas of them may become energized at different points in time. So now you have this concept within your design philosophy of partial posting, of taking some portions of your design as they become energized and making them available to the as-built view. Okay, so last slide. Probably the most interesting aspect of design within a utility and how it relates to modeling and some of the things that we're seeing is this idea of design optimization, which has been talked about quite a bit today. But within a utility, the way they perceive that is if they've got, for instance, a subdivision, and they really want to optimize that design, because what happens frequently, designers will overbuild. They could use a 25 kVA transformer, but it's easier just to throw out a 50 kVA transformer and bring more power. But that's not exactly the most efficient or economical way of doing that. So now what we are seeing a lot in our industry, of course, is that this idea of optimization where you take the parcels and the system, the GIS, figures out what the front lot is and what the rear lot is. You put information in about load and capacity and that sort of nature, and the design actually gets built for you by the GIS. And now you have this highly optimized design. Now this will vary tremendously based on what you're trying to optimize on. That might be energy usage or that might be cost. So I think the interesting part about this, and as we're looking forward, one of the things that utilities don't necessarily take into account with optimization today is the wealth of all that other rich data that's out there. The subsurface environment, things like soils have an enormous effect on the cost of a design. Things like looking at the aesthetics and the 3D aspects of where conductors are going and where those crossings are. That's all critical. And as we think about design optimization in a utility context, that certainly seems to be the direction that we are going. Thank you.
I hope you're getting this notion that there's design in many different fields. And that just excites me because the notion of transference of method from something like this to land use planning, or the transference of field design to all kinds of design, whether it's designing Starbucks locations or commercial facilities. I'm just very excited anyway.